Hi everyone. Today we're going to do the second lesson of Unit 4. We're going to talk about other random sampling methods. In 4.1a, we just talked about simple random sampling, so there are other methods that result in unbiased data, so we're going to talk about those. So we'll distinguish a simple random sample from a stratified and a cluster sample, and then we'll give advantages and disadvantages of each of those. So for the stratified random sample, what you want to do first is classify your population into groups of similar individuals, which we call strata. And then within each of our strata, we take a simple random sample. We call this method sum from all. So we take some people from all of our strata. A really easy example of this would be using your grades as the strata. So if I wanted to take a sample from O'Connor, I would classify you guys into freshmen, sophomore, junior, seniors, and then I would take some people from each of those categories. It just guarantees I get a more representative sample. Theoretically, if I was sampling from O'Connor and I just did a simple random sample, I could get all seniors, for example, which wouldn't exactly be representative of the population. So by stratifying by grade, that guarantees I get some from each category. So here's the example we'll do. The manager at a beachfront hotel wants to survey, that should say guests, not Gus, in the hotel to estimate overall customer satisfaction. The hotel has towers, an older one to the south, a newer one to the north. Each tower has 10 floors of standard rooms, so 40 rooms per floor, and then 2 floors of suites, 20 suites per floor. Half the rooms face the beach while the other half face the street. There are 880 rooms total. So explain how to obtain a stratified random sample of 88 rooms and justify your choice of strata. So the best way to stratify here would to be by room type, because we kind of have a lot going on actually in this example. So there's 2 towers. The south tower is older. So south tower is older, and then we have the north tower, which is newer. So clearly we want to get rooms from both towers because the rooms are different. That's probably going to affect customer satisfaction. A couple other things that would affect customer satisfaction is the type of room they have. So we should definitely try and get standard and suites into our sample. And then the last thing that will affect customer satisfaction is their view. So obviously people with a beach facing room will probably be more satisfied than people facing the street. So let's stratify by all of that. So the south tower, we have 10 floors of standard rooms, 40 rooms per floor. So that means we have 200 facing the street and we have 200 facing the beach. With the suites, we have 2 floors, 20 suites per floor. So that's 40 suites total. So we would have 20 facing the street and 20 facing the beach. Same going on in the north tower. We have 200 facing the street, 200 facing the beach for our standard rooms, and then we have 20 and 20 for the suites facing each direction. So those are our 880 rooms. And when you guys stratify, you want to make sure that you're taking a proportional amount from each. So in this case, if we want a random sample of 88 rooms, we should take 20 from each of the standards and then 2 from each of the suites. So here's how we're going to explain it. So we are going to stratify by tower, room type, and view. And this is because all of those things are going to affect a customer satisfaction. So we are going to separate by north and south, the view, and then the room type. We would label the south street rooms 1 to 200 the South beach rooms, I guess I should put in standard here, 1 to 200. The South Street Suites, that's an E, 1 to 20. And then the South Suite beach rooms, 1 to 20. So then what we would do is we would use a calculator. You could use the random digit table. I'm just going to say use technology, aka our calculators, to select a simple random sample of 20 South Beach, South Standard beach rooms, 20 South Standard Street, 2 South Beach Suites, and 2 South Street Suites. And then we can repeat for the North Tower. Whew, that was a lot of writing. My hand hurts. Okay, so that way it's proportional, right? If we get 20 South Street, 20 South Beach, and then 2 of the suites from the street, 2 of the suites from the beach side, and then do the same for the north, that's going to give us 88 rooms, and everything is proportional to the amount of rooms total. Okay, let's move on to cluster. Oh, sorry, just kidding. Let's talk about some advantages and disadvantages to stratifying. So advantages, it helps ensure that the sample is representative of all the subgroups within your population. In the example we just did, the way that we stratified, we were able to get rooms of all types within our sample. That way we can guarantee that we have a representative sample for our population. No group will be over or underrepresented. It reduces the variability that is possible in a simple random sample of the same size. So in the last example, if we had just done a simple random sample of all 880 rooms, that would have, I mean, we could have gotten all standard rooms in the South Tower theoretically, and then that wouldn't be very representative of the experience of everyone at the hotel. Okay, disadvantages, when you're making your sampling frame, you need to know something about the population, right? If you can't, for example, with talking about O'Connor, we would have to know not only the people's names that go to the school, but we would also have to know their grade. So you need to know characteristics about your population that you can actually use to stratify. That's difficult to do when your population is large. It's also more difficult to do statistical analysis with a stratified random sample. We'll talk more about this when we do inference second semester, but it just makes things a little bit more complicated. In some cases, it's difficult to obtain a stratified random sample since you need to know that information about the population in advance. This is why, I don't know if you guys have ever actually talked to a telemarketer before. Sorry, there was like a little spider here. I had to kill it. But sometimes when you actually talk to a telemarketer or someone trying to call you to answer survey questions, they'll ask you demographic questions so that they can actually stratify you before you answer. And they'll keep calling until they have enough subjects for each of their strata. Okay, let's talk about cluster random sampling. So to get a cluster sample, you start by classifying the population into smaller groups, which we call clusters. These clusters should mirror the characteristics of your entire population. So each cluster should contain people or items that represent the entire population. And then you choose a simple random sample of clusters, and all individuals in the chosen clusters would be included in that sample. So we call this sampling method all from some. You choose some clusters and you sample everybody in that cluster that was chosen. So let's go back to our hotel. Same situation, same room types. For convenience, a manager suggests that a cluster sample be used using the floors in each tower as clusters. So let's explain how to obtain a cluster sample in this manner, and we'll talk about one potential drawback. So we're going to use the floors as the clusters. So let's see, we have 10 floors of standard rooms and 2 floors of suites. So technically that is 12 per tower, so we have 24 floors total. So we would label the floors 1 to 24. He wants a sample anywhere from 60 to 120 rooms. This one's a little different because some floors only have 40 rooms versus 20 rooms. So if we want at least 60, we would have to take a simple random sample and choose 3 floors at least. Because if you got all suites as the floors that were randomly selected, there's 20 suites per floor, so that would give you 60 rooms. If you got all 3 floors that were standard rooms, that would be 40 per floor, so that would be 120. So this way we'll get anywhere from 60 to 120 floors. And we'll say using technology to do that. Okay, so we would label all the floors 1 to 24. We would use our calculator to randomly choose 3 of those floors, and then we would sample every room on the chosen floors. Maybe you can hear my baby crying in the background. I apologize. So the potential drawback to this is we could get all suites or all standard, and then that would not be very representative of the entire population, but sometimes that happens. This was a pure cluster sample where we clustered by floors. Theoretically, we could stratify and cluster at the same time. We could stratify by room type, and then we could choose floors for each room type. So we could guarantee to get both of those. But the way that we did it here was just a pure cluster sample. All right, let's talk about some advantages and disadvantages. Sorry, those popped up on the bottom. We'll talk about them in a second. So advantages, it's cheap, it's quick, it's easy. Instead of sampling an entire country, when using simple random sampling, researchers can allocate limited resources to like few selected clusters or areas. It just makes it easier to access. It's easy to increase your sample size this way because even with the hotel, it would be annoying to have to go all over the place. With the floors, it's really easy to go to one floor, sample every room. So it's easy to increase sample sizing when you cluster. Disadvantages, it could be not very representative of the population. Theoretically, individuals within a cluster should have similar characteristics. The individuals within a cluster should be representative of the entire population, but in our case, when we clustered by floor, those clusters technically weren't representative of the whole population. Some floors only had standard rooms, some floors only had suites. So sometimes with cluster sampling, there is a chance that you overrepresent or underrepresent a certain population, which can skew the results of your study. There is a possibility of high sampling error due to limited clusters being included in the sample and leaving a significant proportion of the population unsampled. So it's really